So anytime you want to sketch the graph of a rational function, and then we also want to state the domain, step one is factoring completely. Well, in this one we have a difference of squares on the bottom, x plus 5, x minus 5, and after you factor it completely, you can list your non-permissible values. X can't equal minus 5, and x can't equal 5. Now we have to decide if those non-permissible values end up being wholes or vertical asymptotes. And they're both going to be vertical asymptotes because none of them simplify to go away. So we're going to have a vertical asymptote at x equals negative 5 and x equals 5. Okay? Nothing simplified. We don't have a green equation. Next asymptotes, we have to decide if there are horizontal asymptotes or oblique asymptotes. So we have to look at what type this is. This is the type where you have the same, you have a parabola on the top and a parabola on the bottom. Same degree on the top, same degree on the bottom. That will always be a horizontal asymptote. And then you look at the coefficients of the highest power. So on the top, the x squared has a minus 2. On the bottom, the x squared has a 1. So that's just y equals negative 2. At this point, I would start the graph. Once you've got all of your asymptotes, I would start the graph. Asymptote at minus 5, asymptote at 5, and horizontal asymptote at minus 2. If you have all of your asymptotes in place, we can now start finding x-intercepts and y-intercepts and any other points that we need. Can you see that this time your graph is separated into 3 different sections? Y-intercept is always the easiest because you just plug in 0 for x, and we get 0 over negative 25. We get 0 for 1. Okay, interesting. Next, x-intercepts. That's only where your numerator is equal to 0. And the only place that your numerator can equal 0 is if x is 0. In fact, it's your y-intercept and your x-intercept are the same point. Now, do we need to find other nice points? Absolutely. Can you see that you have no points in section 1 and no points in section 3? So, for example, I would pick a point like negative 6 in section 1 and see what I get. In fact, I'll put it right here. I'll just do my mental math this way. Negative 6 squared is 36 times an 8. That'll be negative 72. Doesn't seem like it's going to be a very nice point, but we'll see how it goes. Negative 72. This negative 6 would be negative 1. This negative 6 would be negative 11. And if we simplify that, I'm going to just leave it as a fraction. Negative 72 over 11. Yes. Yeah. Can you see that this is between 66 and 77? It's going to be somewhere between negative 6 and negative 7. So if I go to label it, it's going to be negative 6, comma, negative 72 over 11. And that's enough to draw this section. Has to go towards the asymptotes. Section 2. This is a little bit problematic because I've got one point, it's on the x-intercept. We know that graphs could go through an asymptote in the middle. So I don't know, does this go up towards an asymptote or down? And on this side, does it go up or does it go down? So I might like another nice point. I'm going to start by plugging in positive 4 and just see what happens. If I plug in positive 4, go to these brackets, new seating plan here at the back of this one. Oh. So if I plug in positive 4, 16, the top is going to be negative 32. 4 plus 5 is 9. 4 minus 5 is negative 1. I get positive 32 over 9. Right. Again, if you had to estimate that, can you see that that's somewhere between 3 and 4? Because 32 is between 27 and 36, so somewhere between 3 and 4, I can label this 4 comma 32 over 9. Can you see that if you plug in negative 4, especially if you look at the original equation, since x is getting squared, 4 squared and negative 4 squared are exactly the same number. So because of that, if I plug in negative 4, I would also get positive 32 over 9. And with those 2 points, I now know my graph goes up towards the asymptotes. Can you see that your x-intercept of 0 has a multiplicity of 2? Because it's an x squared. So the bounce off the x-axis kind of makes sense that way. Similarly, for section 3, if you plug in positive 6, it'll do the same thing as negative 6. So over here, I could label 6 comma negative 72 over 11 as well. And we would get this as our final graph. So this is an example where usually your x-intercepts and y-intercepts help you. In this one, your x-intercept didn't help you in any of the sections. You had to do a bunch of other nice points. When things aren't helping you, just keep finding more nice points. Keep plugging in values until you get a feel for it. If you think something is not looking right, it's probably because something went wrong. So you're like, this graph isn't looking right. Maybe one of your points has a mistake in it. Sometimes when we do our mental math, we make a mistake. So if you have a point that seems really strange, double check the math. All right, questions to circle for number 2 is just question number 4.